Hello and welcome to the third module of Machine Learning and Data Science course. This week we'll be discussing on how we actually start to work with data. See, data is the first frontier. It's in the very crux of any machine learning or data science model. Without understanding the type of data we have in hand, we can't actually go ahead and start building a model. For example, there are particular task in machine learning which is called as classification. If a particular data set has to be classified into different classes, then we can apply that model. But if we don't understand what kind of information that data represents, how are we going to actually build a model for that? So for all these reasons, we first have to start to understand the data. We first have to interact with the data, get as much knowledge about it as we can, and then depending on that, we can actually start building our model and performing different various tasks using that model and that data. Along with that, one another thing is that machines understand numeric data more than we can. See, for us it's much easier to understand pictorial data, or let's say text, or anything like that. But for machine, everything is representation of numbers, right? So any image or any text or anything like that, even music, all these things can be actually represented as numbers, and these numbers is what actually we feed to a machine learning or data science model. So we get to know that machine learning or any computational model actually understands data better when it's in numeric form. So for that reason, most of our data is in numeric format. And to get started with the understanding all these things, we first will learn how data is actually classified into different types. And after that, we'll skip this for now. We'll go to directly understanding about exploratory data analysis and what it actually does for our machine learning model, how is it useful, and gradually we'll move towards analyzing, cleaning, and manipulating and rescaling of data, and what roles do they play in our data pipeline or machine learning pipeline. After that, we'll discuss a very little on dimensionality reduction of data, the very basics of it, because we are going to be discussing it later in the course when we read about PCA and a little on TSNE. But for now, we'll get to know what dimensionality is, how it can actually affect our model and all these things. After that, in the end, we'll see a web scraping model that we'll be building from scratch. It's not a complete model per se, but it's just a function that we are going to be writing from scratch in Python, so that we can get web data or the data from the websites, different websites. For today, we'll just scrape some financial data related to some stocks from Yahoo Finance. Other kind of data can be scraped in various ways, but for now we'll just build one particular data scraping method. So without wasting much time, let's get into classification of data. So let's get into the classification of various data. So the very first kind of data that we face in any machine learning project is continuous data. So what is continuous form of data? Any data, any numeric data actually that doesn't have a interval of more than 1 unit is called continuous. Means, for example, if I say my data lies between 1 and 2, what does it mean? How many numbers are there between 1 and 2? If we are thinking in terms of real numbers or float values, then we have actually infinite number of values lying between 1 and 2. So this kind of data is called as continuous form of data. Means they are continuous, there's no break between one value and another value, and there can be infinitely many points between a given range of values. Another form of data is known as discrete. It's kind of opposite of what continuous data is, but it's related but kind of opposite. So what discrete data represents is that there's a particular interval at which you will find the data. Means data points lie afar from each other at regular intervals. For example, if I say that I have a set of numbers, integers for to be particular. So integers actually are discrete form of data. Means they represent data at regular intervals like 1, 2, 3, 4, up to infinity and up to minus infinity as well, but they are at a regular interval. This kind of data is actually called discrete form of data. Means we can count the number of points there are. There may be 1 to infinity or minus infinity to infinity in the range, but we can still count for a given particular range of numbers that the total count, what the total count is. Another form of data is categorical. So in various machine learning models, what happens is that a particular set of values represent different types. To explain types, let's say for example there are flowers. So flowers can be actually classified into various types like rose, lily, sunflower, or whatever. So there are various kinds of flowers. So what are these flowers? If I'm performing a machine learning task in which, given the data about those flowers, I have to actually classify them into various types. So this basically is a categorical value, means different categories are represented by different numbers or different names or different strings, whatever there can be. So yeah, this is what categorical representation of data is. Then comes binary kind of data. So what kind of representation can be classified as binary? Let's just say there's a task in which you have been given banknotes. Every note in a bank has to be either real or it has to be fake. Depending on different attributes of the note, you are given the task to actually classify that note or various notes as real or as fake. So what do? You analyze that note and then you come to a conclusion that either it's a real note or it's a fake note. So how many how many categories are there for you to classify that note into? There's real and there's fake. So it can be either one of them. It can't be both of them. It can't be anything other than that. So this kind of classification or this kind of data representation for now is called as binary data representation, in which there are just two values that represent the state. For example, 0 or 1, true or false, are representing two states in which a particular value can exist. Other than that is ordinal kind of value. So what ordinal data represents is that it's basically categorical data but which has a meaning to it, means there's an ordering to that category. For example, sunflower, lily, rose, they don't have any relation among them in terms of continuation or in terms of ordering. But for example, if you go to Amazon or any other website where you can rate a product or you can rate the service, then you have the option to rate the service from 1 to 5, let's just say. So 1 to 5 has an explicit relation, even though there are just 5 categories in which you can rate that a particular item. Category to name are 1 star, 2 star, 3 or 4 or 5 star, right? So even though there are just 5 categories, they have a particular meaning associated with them in terms of relativeness to each other. 1 is always going to be less than 2, 2 is always going to be less than 3, and so on. So there's an ordering to the categories. This is what ordinal data represents. Categories can be general categories, but ordinal data has to have an order to the data that they are representing or the categories that they are representing. Now, the major portion of machine learning that we are going to be exploring throughout the course depends on a particular kind of data representation that is known as rectangular data. So what rectangular data means? It basically means that our data is going to be in form of a table, a spreadsheet, or whatever you like to call it, depending on your experience. So every data, for example, if you have studied database management system yet, so you must have faced various tables in which data is represented in form of columns and rows. So what does each column represent? It represents an attribute or it represents a feature of that particular data. For example, the very basic table employee has attributes like employee ID, employee name, employee date of birth, date of joining, and all these things. So what does all these things actually represent? They represent the state of an employee, or they represent what an employee is. So if an employee is, for example, if there's a attribute called as employee rating, and the employee rating is from 1 to 10 and a particular employee has a rating of 1, then you can actually infer that that employee didn't perform well in his work at the office, right? So every attribute has a specific meaning associated with it in the form of various data categories that we just understood. Other than that, there are rows. So each row represents one entry or one employee in our case. So for per se, uh, there are various rows in a data frame which represent various instances, and there are various columns which represent different attributes or different features for our machine learning context. We call them features, and you might have called them attributes if you have studied database system. So yeah, each column represents a feature, each row represents another data point.